All right, so what do you notice? What do you wonder on here? So what's the first thing you notice on this? There's 4 lines. Cool. Okay. Anything else? They all have the same y-intercept. Okay. Are they all growing at the same rate? No. Okay. What about this yellow line or this black line compared to the blue line? Going down. What words did we use yesterday? Not decreasing, but close. Decay. So this guy is decaying, and these guys are growing. Yeah. Okay. And we don't have to do the wonder part. That's okay. Cool. All right. So today is key features. This is the majority of your interim. So when we take the interim, it's like right after spring break. That's what this is going to be majority over. Okay. So today, pay attention. Tomorrow, pay attention. Okay. All right. So first thing I'm going to show you is just kind of like a little anchor chart. Ooh, okay. Anchor chart. Now you don't have this in your possession, but I just want to kind of show you a couple of things. So we just talked about the fact that there's exponential growth, exponential decay. Everybody's good on that. You also told me the y-intercept. Okay, so that's obviously a key feature, right? Okay, and that's when x equals 0, that's your y-intercept, right? Okay, now we've got this thing called an asymptote. Okay, so we got this thing called an asymptote. I would write this on your paper under that little like empty space. Asymptotes are where the line approaches, but does not touch. Okay. The way we always remember this is don't touch my asymptote. Haha, no. Okay, just me. So asymptote is definitely something that you're going to want to know. Now, in math, we have horizontal and we have vertical. Exponential functions only have a horizontal asymptote. Okay, so we see how this line curves and gets really, really, really close to this line of y equals 4. It doesn't actually touch it. It gets very, very close. Those decimals get really, really close to it. Okay, same thing over here. There's an asymptote that's right here. Okay, now when you graph this, you're not going to see this dashed line. Okay, this is what we've drawn for you. This is just a visual for you. Okay, now domain for all exponential functions is all real numbers. On your paper, I would write domain, all real numbers. And again, you're just putting this like on your paper underneath that box of what we're going to learn today. The range is always going to deal with the asymptote. Okay, so you're going to find the asymptote and it's either going to be above or it's going to be below that. Okay, I'm going to get rid of all this craziness. Nice. Okay, in behavior is just like what we've done in the past. As we move to the left, we're going to approach that asymptote. As we move to the right, we're going to positive infinity. So again, just looking at the end result. Okay, if it's growing, it's never decreasing. If it's decaying, it's always decreasing, right? Okay, and then we still have the whole, if it's above the x-axis or if it's below the x-axis, right? Okay, so those are just the key features that we were going to see. Now, we could have something like this. This is still an exponential function. This is still growing, but it's a reflection. I need you to look right here. If you see a negative out front, that means that it's reflecting. Okay. Now, this is still considered growth, but it's just a reflection. Okay. Yes. We're just going to fight the projector today. Yay, yay, yay. Looking at your notes, okay, we're going to talk about in behavior. Okay, so we got this graph right here. Okay, here it is in graph form, and then here it is in table form, and this is on your paper. Okay, so talking about in behavior, as x is approaching positive infinity, so as we're moving to the right, where is it getting closer and closer to? What y value? Okay, let's have this conversation first. Where's the asymptote? Where does it approach but never touch? Like, where does it kind of curve off? What y value? You gotta look. What y value does it get closer and closer to? -6, right? Okay, so our asymptote is at -6. So we have an asymptote at y equals -6. Okay, so we see that little yellow line that I draw? That's your asymptote. So as x is approaching positive infinity, that means as we're going this way, where are we getting closer and closer to? What y value? What's the asymptote? -6. Okay, so y is also approaching -6. As we move to the left, so as we go to the left, where are our y values going? They're going up. They're going infinitely up. So it's going to be positive infinity. Now, this is a little bit harder in a table in order to see. But we also see that if this is exponential, which this is because we're multiplying by 5 each time, everybody can see that, right? This is exponential. As we're increasing our x values, it's going exponentially up, right? So looking at this table, this is separate from this graph, right? So looking at this table, as we move to the right, what's happening to our y values? As we move to the right, what's happening? They're going up, right? As we move to 0, where did our y value go? So 5. So because I have this table, it's kind of hard to see what the next number is, but what would be the next number over? Actually, I take this back. What would be the next number over? Like going backwards. So we're multiplying by 5 each time. So we would have to divide by 5 in order to get the next number backwards, right? So what's 5 divided by 5? Okay, what's 1 divided by 5? You're gonna have to type that in your calculator probably. 1 divided by 5, what is that gonna be? Okay. And then if we took that and we divided it by 5 again, we would just get closer and closer to what number? It would just be a decimal, right? So we get closer and closer to 0. But as we're moving to negative infinity, we're actually getting closer and closer to 0. We can build that table if we know the pattern. Okay, so this guy goes with the graph. This guy goes with the table. On your interim, you will have at least one question on in behavior. There will be one like this. It'll either be in a graph or in a table form. Okay. All right. On the next one, we've got g of -2 and f of 2. Okay, so looking at this, when we talk about g, which one are we talking about, the graph or the table? And how do we know? We're looking at the graph. Why? So if we're talking about g, what are we talking about? We're talking about the graph. Why? Because it says g of x, right? If we're looking at f of x, f of 2, we're looking at this table. Everybody see where I get that from? Okay. All right. So if I'm looking at this, when x is -2, so when x is -2, what's our y value? So we go over to -2, we go where the line meets. What's our y value? Okay, so g of -2 is -2. Okay, on this one, when x is 2, what's our y value? Dude, every day. This is rough, bro. When x is 2, what's our y value? Look at your table. When x is 2, what's our y value? Ooh, when x is 2 on our table, 125. Okay, so again, you got to pay attention to, are they talking about the table or are they talking about the graph? Yeah? That will be on your intro. Okay, that's also on your SAT. They always ask those kind of questions. All right, now domain and range. In a biology lab, bacteria reproduce by splitting every hour. Each bacterium divides based on a pattern. A biologist is examining 2 different petri dishes as shown in the graph below. And table. Okay, so there's 2 different petri dishes, and we're saying the domain and the range, right? Okay. So for domain, that's our x values, right? So for our x values, how far to the left do we go? What x value do we start with? 0. And how far to the right does it go? It keeps going on, right? So we're going to say infinity. Now, on a test, it might only give you the answer choices of 0 to 4 because that's where our graph is, right? Okay. However, for this purpose, we're going to put infinity because it has an arrow. Okay. For the range for the graph, what's the lowest y value? Where do we start? 500. How high does it go? It goes infinity, right? Now, again, on a test, it might just say 5,000 because that's the biggest depiction that we have. You know, eventually the bacteria would probably die off. Eventually the bacteria would probably get killed by something. But in this scenario, they have an arrow. Does that make sense? Okay, on the next one, for domain, we're looking at our hours. Okay, so how long are we looking at? What's the first number they give us? What's the last number they give us? So from 0 to 3. Now for range, what's the lowest y value they give us? And what's the highest? Okay, so from 500 to 4,000. The table's a little bit easier to deal with, okay? And again, it's based off of the information that they give you, okay? I don't like putting infinity on domain and range, but since they put that arrow on there, it could go on forever, okay? Questions over that? Okay. All right, so was there anything that you want to talk about? The ones that are on the back? Anybody have any problems with the ones on the back? I see a lot of writing, which means, do we get to write or not? Everybody understand G, H, and I? No questions on that. Okay. H always trips people up by that meaning. Okay, yeah, what's F? I got agree. Because it was talking about this guy. I'm going down each year. Cool. Okay. All right, so I do want to do a little bit more practice on this. So on partner A's worksheet, that looks like this. It is not the same front and back, just FYI. Okay, it asks this question of decay factor. Okay, so in order to figure out what the decay factor is, you're going to take the second number and divide it by the first. So what I mean by that is we see it goes from 400 to 200 to 100 to 50, right? We see it's going down. So we're going to take the second number and divide it by the first number. So what's 200 divided by 400? If you don't know, type it into your calculator. You're going to tell me that's 0.5, right? Okay, so that's going to have a decay factor of 0.5. So when you are asked this question, it's your second number divided by your first number. If you're given a graph on this and they ask you for the decay factor, it would be your second number divided by your first number. So this would be 2 divided by 8. Does everybody see that? Yes, no, maybe. Okay. So what I want you to do is find somebody who has the opposite. So if you're partner A on your worksheet and all you got to do is look up at the top, then you need to find a partner B. Okay. And y'all can work together. Okay. But you're trying to complete the front and the back. Okay. We've got a couple of minutes. So if you don't finish this up, it'll be homework, but go ahead and start working on it. Same types of questions you were doing out in the hallway. Same types of questions. Okay. All right. So go ahead and get started on